Yes, sir. Am I audible?
Yes, you are audible now.
Awesome. Awesome. Yes.
Yes, अब हम डिस्कस करेंगे OMC ऑर्गेनोमेटेलिक
Compound or yes. Sir.
Yes, what the main application of OMC?
Sir, actually, organometallic complex is basically used for the catalysis. Okay, mainly we can use organometallic compound for catalysis reaction. For catalysis reaction, suppose for hydrogenation of alkene or formation of alcohol to aldehyde. For hydrogenation of alkene, we use that Wilkinson catalyst, or for that means for the preparation of alcohol to aldehyde or carboxylic acid, we use rhodium organometallic complex, like that. The main application of organometallic is the that means for the preparation of that means to pass the chemical reaction, use catalyst. That means the formation of catalyst, the main use. Yes.
Main is
And yes, sir. And from organometallic catalysis, we can form we can synthesize anti-cancer drug with the help of some type of transition metal. Suppose transition metal like molybdenum, platinum, palladium. We use, yes, this type of ligand with the help of coumarin ligand or something like that. We can form that means anti-cancer drug, anti-malarial drug, antibiotic, all we can form. Yes, sir.
Yes, what the difference between 18 electron rule and ENA rule? What the main application of these?
Sir, EAN rule, 18 electron rule tells about the organometallic complex. Those if that means the atom have 3 orbital. That means transition atom has 3 orbital in it. That means one is s orbital, one is p, and one is d orbital. S orbital can contain 2 electron, p orbital can contain 6 electron, and d orbital can contain 10 electron. So if the atom contain 18 electron in its valence shell, okay, then the complex is stable. Okay, this is the basis of 18 electron rule. That means if a compound, organometallic compound, contain 18 electron in it, then it is stable. So EAN rule is the effective atomic number of electron. That means a complex, those have that what is called basically EAN rule is 1 minute, sir. EAN rule that means that much electron in it. I mean, जो है वो है मतलब. हाँ sir. Yes. हाँ sir. Is it okay? EAN rule तो मतलब 18 तो बोल दिया मैंने. EAN मतलब कुछ गड़बड़ हो गया था. EAN
इफेक्टिव एटॉमिक नंबर. यस, इफेक्टिव एटॉमिक नंबर का एग्जांपल बताइए कोई सा भी.
Sir, effective atomic number we can 1 minute, sir. Suppose effective atomic number we can calculate for Fe(CN6) 4-. Okay, Fe(CN6) 4-. Iron has total of kitna electron? Iron, here the iron, 1 minute. Iron is in configuration of +2, 24 electron, +2 into 6 +4. That means 16, 40. That is the effective atomic number. That means iron, whole molecule has total of 40 electron in it. Okay, and the 18 electron rule basically tells about the valence electron. Okay, valence electron, and effective atomic number basically tells about the whole number of electrons. Yes, that is the main difference, I think. If EAN is talking about the EAN talk about the basically the whole number of electron from the ligand to metal. That means ligand and metal considering and charge. Okay, and for 18 electron rule, we calculate only the valence electron of metal and the ligand. Yes. Suppose I am taking NiCO4. Okay. Suppose I am taking NiCO4. Nickel has valence electron of 10 electron plus 4 into 2. Cobalt, carbon can donate 2 electron. So total number of 18 electron. Okay. So that is the main. Yeah. Yes. This is the EAN and this is and for this, if EAN we can calculate, nickel has valence electron of 28 plus 4 into 2. That means 28 plus 8 is equal to 36 electron. That is the effective atomic number, and that is following 18 electron. Is it okay, sir? I am explaining through NiCO4. NiCO4 follow 18 electron, and the effective atomic number of NiCO4 is 36 electron. Yes. Though I don't know the proper definition of this.
No problem. Example होगा. Yes. ये बताइए which compound is does not obey the ENA and 18 electron rule.
Sir, basically, 18 electron complex. Suppose main group element. That means alkali metal element. Suppose Grignard reagent. All these type of things. Grignard reagent, alkali metal. That means RLi lithium atom, lithium alkyl lithium. This reagent cannot follow 18 electron rule or 16 electron rule. Basically, is it okay?
Yes. FeCN का whole 6 3 negative.
हाँ सर. FeCl का whole 6 3 negative. इसमें तो 18 इलेक्ट्रॉन. हाँ सर.
Yes, 5 plus 12 17 electron.
हाँ सर.
23 plus 35 electron.
हाँ सर. Yes.
Next, go through any example of a coordination compound. Explain.
अच्छा. Coordination compound.
Yes.
What I have to explain, sir?
Any example. Coordination compound. Example.
उसका मतलब क्या?
Example of coordination compound. How to explain?
Yes. This one. FeCN6 4 minus. This is the example of coordination compound. Yeah. Yeah. Okay, sir. So here that means the iron and cyanide lost their identity basically. Iron and cyanide lost their identity, and these are in a complex format. This both simultaneously. That means whole can act as an ion. That means a negative ion. Yes, negative complex, anionic complex. This is the example of anionic complex. Yes.
Yes, metal ion, ligands, ionization sphere, coordination number, coordination sphere.
Sir. So here iron is that means coordination complex are basically formed by transition element. Coordination compound basically formed by transition element. So here the transition element is iron. So iron is central atom, and cyanide that is the ligand. Okay. And this whole is called ionization sphere. Whole is called ionization sphere. Okay. Yeah. Then metal and the ligand whole is called ionization sphere.
Yeah, next move on. Next topic is Wagner theory. What the main application of Wagner theory? What the uses of Wagner theory in application chemistry?
Yes, sir. From Wagner theory, we can predict the two type of things. That means from Wagner theory, we can tell about that metal has two type of valency. One is primary valency and one is that is called secondary valency. Okay, metal has two type of valency. One is primary valency and one is secondary valency. And primary valency are stabilized. Okay, that is primary valency are stabilized by anion. Okay, primary valency are stabilized by anion and secondary valency are stabilized through ligand. Secondary valency are stabilized through ligand. Okay, that is the from Warner theory we can get this, and from Warner theory we can predict the coordination structure also. Yes, coordinate complex structure also from Warner theory. Suppose I am taking one example, CO NH3 6 whole 3. Okay, so here this chlorine is balancing the primary valency. So that is cobalt. Cobalt has primary valency. Cobalt has primary valency of equal to 3, and this cobalt is surrounded by 6 ligand. So secondary valency, cobalt is surrounded by 6 ligand. So secondary valency is 6. Yes, secondary valency is 6 and primary valency is 3, because this cobalt is surrounded by 6 ligand. So surrounding ligand is called basically is secondary valency and one is called primary valency. Yes, sir.
Yes, what the difference between primary and secondary valency? Any example?
Yes, sir. I have already give this example. CONH3Cl3. The cobalt has primary valency of here. Primary valency is that means balanced by countersent by Cl3. 3 chlorine atom. So that means cobalt has +3 of primary valency. Cobalt show oxidation state of +3, and the secondary valency is 6. Yes.
Yes, any drawback and limitation of Warner theory?
From Warner theory, we cannot predict the exact, that means the exact structure, or we cannot predict the paramagnetic and diamagnetic character of the complex. We cannot predict the, that means we cannot predict color of the spectra also. We cannot predict color of the spectra also. Color of the transition coordinate complex. Yes. Yes.
Yes, good. Next, move on ligand. What the main application of ligand?
Sir, ligand is basically those type of substance which has lone pair of electron on it. Okay, so ligand are those type of substance which has lone pair of electron on it. Okay, so ligand can be of two types. Okay, ligand can be of three types. One can be of neutral ligand, one can be of cationic ligand, and one can be of anionic ligand. Suppose cationic ligand, water is there, so water has lone pair of electron, so it can donate electron to metal vacant orbital. So therefore water can act as a ligand. Similarly, ammonia has lone pair of electron, so ammonia can also act as an ligand. Suppose I am taking the NO positive molecule. NO positive has lone pair of electron on nitrogen atom. It can also act as a ligand. And I can take example of anionic ligand, Cl minus, Br minus, NO3 minus, iodide minus. All are the example of anionic ligand. Yes, sir. Ligand basically donate each electron pair. That means the non-bonded electron pair to the metal vacant side, metal vacant orbital. Yes. From the ligand, we can with the help of metal, if a metal react with a ligand, then complex can form. Yes, sir.
Yes, what the difference between negative, positive, and neutral ligands? What the example?
Yes, sir. I have already discussed that neutral ligand are those type of ligand which has only lone pair of electron, but there is no charge. Okay, so we can take example of water ligand, water has two lone, oxygen has two lone pair on it. So therefore oxygen can act as a ligand. Similarly, the ammonia also has one lone pair on it. So ammonia can also act as a neutral ligand. So similarly, cationic ligand is, suppose I am taking NO positive nitrosyl ligand. It can act as a cationic ligand since it has positive charge on it. Similarly, for anionic ligand, I can give example of Cl minus, Br minus, iodide, NO3 minus, cyanide, SCN minus. All can donate it. Since it has lone pair of electron on it, it can donate electron to the metal. So since it has negative charge on it, it is a negative ligand. Yes, or anionic ligand.
Yes. What is ambidental ligand? What the main application of ambidental ligand?
Yes, sir. Ambidental ligand are basically those type of ligand which can donate each electron pair through two different sides, but only at once. Okay. Suppose I am taking Cn minus ligand. So Cn minus ligand, here. Okay. So here carbon has negative charge and nitrogen has lone pair. That means carbon can donate the lone pair of electron to it, and similarly nitrogen also can donate the lone pair to the metal. So therefore it acts as cyanide acts as ambidentate ligand. Cyanide acts as ambidentate ligand. Okay, cyanide acts as ambidentate ligand. Similarly, NO2 minus, oxygen can also act as oxygen can donate the electron to it, and nitrogen can also donate it. So therefore, NO2 minus is also an ambidentate ligand. Similarly, SCN minus also act as ambidentate ligand. Yes, sir. These are the example of ambidentate ligand. Cyanide, NO2 minus, nitrite, that is, and SCN minus, thiocyanide. These are the example of ambidentate ligand.
Yes. What is hexadental ligand?
Hexadental ligand, that means those ligand which can donate its lone pair electron to metal through six different sides. Then it is called hexadental ligand. Okay, hexadental ligand is a polydental ligand. Okay, one of the example of hexadental ligand, that is a EDTA, EDTA 4 minus. EDTA 4 minus is ethylene diamine tetraacetate. Tetraacetate is an example of hexadental ligand. Ethylene diamine tetraacetate.
Yes. What is bridging ligand? How many types of bridging? What the example?
Yes, sir. Bridging ligand are those type of ligand which can bridge two metal, or which can bridge three metal also. Suppose I can give example of OH minus. Okay, hydroxide. Hydroxide is one type of bridging ligand. Similarly, carbonyl is one type of bridging ligand. Similarly, Cl minus is one type of bridging ligand. That means those type of ligand which can give lone pair of electron to at a time two metal. That is called basically at a time two, more than one atom, more than one metal. That is called basically bridging ligand. One of the best example is carbonyl ligand. One of the best example is Cl minus. One of the best example is OH minus, hydroxide minus also. Yes.
Yes. What is flagedentate ligand? What the example of flagedentate ligand?
Now, flagedentate ligand is those type of ligand which can change its atom or denticity. Okay, which can change it. Yeah, exactly. I have read more time, but I have forgot. That means those type of ligand which can change its denticity is basically called flagedentate ligand. EDTA 4 minus. EDTA is an example. It can donate through nitrogen, one nitrogen. It can donate through two nitrogen. It can donate through oxygen. So this is called basically flagedentate ligand. Is it okay, sir? That means I can give one example of through organometallic, that is cyclopentadiene. Cyclopentadiene can donate through one carbon also. It can donate through 3 carbon also. It can donate through 5 carbon also. That is called basically flaxi-dentate ligand. That means which can sense their denticity. Is it okay, sir?
Yes. What the difference between symmetrical and unsymmetrical bidentate ligand?
Yes, sir. So symmetrical bidentate ligand I can give, that means those bidentate ligand which are the same side. That means if I put a mirror on it, the two sides are same. That is called basically symmetrical ligand. And if there is two different sides, if I put a mirror, then it is called basically asymmetrical. So I can give one example of ethylene diamine. Okay, ethylene diamine. Suppose you can take here NH2 and NH2. So if I put here one, this side and this side are same. So that is a symmetrical. That is a symmetrical bidentate ligand. That is an example of symmetrical bidentate ligand. Suppose I am taking example of one side COO minus and another side NH2. That is the glycineto complex, glycineto ligand. So here this can act as asymmetric ligand. Yes, symmetrical ligand example is ethylene diamine, and asymmetrical ligand example is glycineto ligand. Yes.
What is macrocyclic ligand? What the main application?
Yes, sir. Macrocyclic ligand. Sir. Macrocyclic ligand are basically those type of ligand which that means which has a very big bulky size. Okay, the macrocyclic ligand is basically benzene type of that means polyene system. Suppose I can give example of porphyrin ring. Porphyrin ring, one of the example of macrocyclic ligand. Corin ring in one of the example of, that means macrocyclic ligand. The macrocyclic ligand is basically formed coordinate complex with iron, cobalt. Yes. So in human body, we have hemoglobin, which is the formation of macrocyclic ligand, that is porphyrin ring system. In chlorophyll, we can cobalt is coordinate, that is called basically one of the example of what is called macrocyclic ligand, Corin ring. Yes, porphyrin ring, Corin ring. Yes. That means it has 4 donor atom. That means nitrogen. It has 4 in hemoglobin. It has 4 nitrogen donor atom in it. Yes.
The next move on. Next topic is isomerase.
सर कोऑर्डिनेशन था या ऑर्गेनोमेट्रिक था, मतलब एक साथ अस्तो?
यस, बेसिक है ना. अब फर्स्ट पॉइंट हो गया. अब सेकंड पॉइंट है आइसोमेरेज, थर्ड आईपीएससी, फिर थ्योरी. सॉरी, वंस अगेन.
हाँ सर.
वो ओएमसी था, वो हम उसके बेसिक पे
एमसी के बेसिक में मतलब आइसोमेरिज्म तो नहीं आएगा.
हम डिस्कस कर रहे थे, वो उधर चला गया. मैं बेसिक क्योंकि ये इसका पार्ट है ना ओएमसी में, तो इसका टॉपिक है मेटल कार्बोनिल. ये तो हम डिस्कस कर चुके हैं, लेकिन वो बेसिक टॉपिक डिस्कस कर रहे थे ना हम, लिगेंड. तो थोड़ा मैं डिटेल में डिस्कस कर रहा था, तो इसलिए वो.
यस.
नेक्स्ट इज मेटल कार्बोनिल. व्हाट द डिफरेंस बिटवीन मेटल कार्बोनिल एंड मेटल नाइट्रोसिल?
Okay, sir. So that means metal carbonyl. Metal carbonyl has exactly the main question is suppose I am taking carbonyl and nitrogen. Okay, carbonyl has 6 plus 8 14 electron also, and it has 3 bond pair. Similarly, nitrogen positive, that means it has 7 plus 8 minus 1 is equal to 14 electron. It has also 3 bond pair. Okay, so carbonyl and nitrosyl are the same type of ligand, basically. But if carbonyl can donate, okay, carbonyl basically from metal carbonyl system. One minute, sir. I can give example. Carbonyl can donate it 2 electron. Okay, yes. Carbonyl can donate its 2 lone pair of electron to metal, and metal nitrosyl can send it density. Okay, metal nitrosyl can be of, that means are of 2 types. Okay, one is bent nitrosyl and one is linear nitrosyl. So nitrosyl basically have 3 valence electron on it. Okay, one is this and one is this. So here, okay, I'm giving an example. That is, if it donates through only this side, okay, so it can give only 1 electron donor. Okay, if it bind through this side, then it is 1 electron donor, and here this can act as what is called linear nitrosyl. Okay, linear nitrosyl. And if it donates through this and this both side, then it is called bent nitrosyl. Okay, if it donate, if it can bind through 2 sides, then it is called bent nitrosyl, and it is now it can act as 3 electron donor. Okay, that is the main difference. Carbonyl is a 2 electron donor, and nitrosyl is a nitrosyl can act as a 1 electron donor also, and it can act as a 2 electron donor also. Suppose I am giving one example, that is MCO6. Okay, 1 minute. NiCO4. Okay, here nickel has 10 electron in it, and 4 into 2, that is called basically 1 minute. That is called basically 8 total 18 electron. Now, if I put my NiNO4, okay, NiNO4, to get the system of 18 electron, okay, nickel has 10 electron. Nickel has 10 electron. 2 nitrosyl can act as 3 electron donor, and 2 nitrosyl can act as 1 electron and 1 electron donor. That means 2 nitrosyl can act as linear and 2 nitrosyl can act as band, acting as a band, and 2 nitrosyl are acting as a linear. Okay, that is the main point, main difference. I have given example now. Yeah, is it okay, sir?
Yes. What is the difference between direct carbonylation and reductive carbonylation?
So direct carbonylation is basically processing through associative mechanism, whereas the reductive carbonylation is processing through that is called dissociative mechanism. I think so. I have not read these things, but yeah, from my point of view, that is direct is basically associative, and that is dissociative mechanism. Is it correct, sir?
Yes, it's correct. Direct example NiCO4. Yes.
Awesome.
Reductive CrCO6.
Awesome.
Next is phosphine. What is the main application of phosphine in OMC?
Yes, sir. So phosphine का main application. phosphine का main application क्या होता है? सर, phosphine तो मतलब कैटालिस्ट में होता है. Yeah. With the help of that means phosphine, suppose I am taking PPH3 ligand. Okay, a PPH3 ligand, we can that means we can, what it is called, we can increase the metal electron density with the help of phosphine, or we can decrease the metal electron density also. Suppose I am taking PR3, so R group is electron donating group, so this PR3 can increase the metal electron density on the metal. Similarly, POAR3, this is not increasing the this, since it is a that means there is one benzene ring is there, so this will not increase the electron density. This will basically decrease the electron density on the metal. Is it correct? Though I don't know the exact application. That is, it is basically used in catalysis molecule also. Suppose RH, that means Wilkinson catalyst we use.
Yes. Next, move on. What the difference between carbene and carbine?
Yes, sir. Carbene has 2 electron on it. Okay, carbene has 2 electron on it, and whereas the carbine has 3 electron or 3 non-bonded electron on it. Okay, so carbene is basically 2 types. One is called singlet carbene, and one is called triplet carbene. Okay, the singlet and triplet carbene is there, and there is nothing like and carbine. Carbine is basically it can be of doublet in nature. Yeah, it is doublet in nature, or it is singlet in nature. Yes, sir. Carbine basically, yeah, triple 2 into 3 into half quadret. One is quadret and one is 1 minute, sir. Yes, plus 1. That I forgot. That means one is triplet. That means 2 into quadret hai. A quadret tha or a 3 potatoes. That means doublet. Quadret and doublet. Yes. Carbine can be quadret and doublet, but carbene can be singlet and triplet. Yes. Is it correct, sir? And carbene are of 2 types. That means fissile carbene and shock carbene is there. Yeah. और क्या पूछो तो क्या होगा, वही तो होगा.
Yes. Shock and fissile carbene. What the difference of fissile and shock? Difference.
Sir, fissile carbene fissile carbene is basically formed by singlet carbene, and fissile carbene is electron deficient in nature, and whereas that means metal which are in high oxidation state that form fissile carbene, and whereas shock carbene are triplet in nature, and that is nucleophilic in character. Triplet carbene are basically formed by shock carbene, and they are nucleophilic in nature. Yes, that is the main difference between fissile and shock. Is it correct, sir?
Yes. Shock is triplet, fissile is singlet.
Yes, sir. Fissile is singlet, and fissile is electrophilic in nature, whereas that is shock is nucleophilic in nature.
Nucleophilic, yes, right.
And fissile carbene obey 18 electron rule, whereas shock carbene cannot obey 18 electron rule. fissile में सिंगलेट होता है, इसमें ट्रिपलेट होता है, और मतलब यहाँ पे क्या बोलते हैं, fissile में इसका ऑक्सीडेशन स्टेट लो होता है, इसमें शॉक में मेटल का ऑक्सीडेशन स्टेट हाई होता है. यस सर. और fissile का metal carbon bond, that means the metal carbon bond in fissile is weak, whereas the metal carbon that means rotational barrier is low, whereas in shock carbene the metal carbon bond is strong, rotational barrier is high. Yes, that is the main difference. All difference from Ajay Kumar I told you. Yes, sir.
What the difference between hapticity and denticity?
Yes, sir. ये मैंने पढ़ा था. 1 minute, sir. Hapticity means इसको क्या बोलते हैं? Number of, that means atom. Okay, number of atom in a ligand that can coordinate that to a metal. Okay, that is basically number of atom in a ligand that can coordinate that to an atom is basically called hapticity. Okay, and denticity is number of electron a metal a ligand can donate to a metal is basically called denticity. Is it correct, sir? Hapticity is number of atom in a ligand that are coordinated to metal center in a coordination, and coordination or suppose organometallic complex, that is called hapticity. Whereas number of electron that a ligand can donate, that is called denticity. Yes. Is it correct, sir?
Yes.
Awesome. That means hapticity we can denote the hapticity by eta. Okay. Suppose cyclopentadiene ion, and if it donate through only one carbon, then it is called eta 1. If it donate through 3 carbon atom, that is it is eta 3. If it donate through whole carbon, then it is called eta 5. That means it has 3 hapticity. Yeah. That means alkyl ligand is a hapticity as 1, whereas the alkene ligand has an hapticity of that is 2 atom is there, that is eta 2. Yeah. And whereas allyl ligand is basically it donate through 3 atom, that's why its denticity is 3. Yeah. That means CH3 CH2, and this is allyl. This can donate through, and this can donate through. Here it has denticity 1, here it has denticity 2, and here it has denticity 3. Yeah. Almost I have explained this. Yeah. Awesome. And yeah. Number of electron pair donated is called denticity, and number of atom coordinated to metal ion is called hapticity. This one I have explained. Alkyl ligand is eta 1, alkene ligand is eta 2, whereas allyl ligand is eta 3.
Yes. Good. Next is what is a flexion behavior in any complex?
Sir, what is
flexibility? What is flexibility? Flexionality.
Sir, flexibility or fluxional. Yes, that means the molecule are not rigid in nature. Okay, that means molecule are not exactly rigid in nature. If the molecule atom or vibrate, okay, then the molecule structure can be changed. Okay, if the conformation have the conformation are equivalent in nature, if the conformer of the molecule that means non-equivalent in nature, then it is called tautomer. And if the molecule has the same conformation, that means the equivalent, okay, then it is called fluxional, and the process is called fluxionality. Okay, suppose I am taking one example is, that means trigonal bipyramidal geometry. Okay, if trigonal bipyramidal geometry, that is I am taking example of Ml5 molecule, Ml5, that means L1, L2, L3, L4, and L5. Okay. Now, if it vibrate, 1 minute, I am giving this as a lower side. I am giving this. This ligand L1 and L4 are axial, and L5, L2, L3 are in equatorial position. Okay, are in equatorial position. Suppose I am taking now, if it vibrate, then this conformation can transmit to like that, only like little bit of vibrate, L1 vibrate to like that, L2 is there. Okay, now L3, now L4. That means there is 4 vessels. Here there is one plane and 2 molecules, one is in upside and one is downside. Now in vibration, okay, in vibration 4 basal point, that means it forms pyramidal like structure. Now that is its name is basically square pyramid. Okay, its name is square pyramid. That means from trigonal bipyramid, due to the vibration of molecule, it converted to square pyramidal structure. Now this square pyramid again, due to vibration, can convert it to that means L2 can go to upside, L1 can come to equatorial position, L3 can come to equatorial position, whereas L4 can come to that means L3 can come to axial position, L4 can come to equatorial position. So in this structure, you can see from trigonal bipyramidal process through square pyramidal, then it converted to that means trigonal bipyramid again. Then it converted to trigonal bipyramid again. This process is basically called very pseudo rotation.